code, all the stuff.
Welcome to this video explaining the difference between Git and GitHub, as well as we will talk about how to properly use the GitHub Flow to manage your large-scale software applications with multiple developers. So let's jump right into it. First of all, I just want to explain that there is a difference between Git and GitHub. A lot of people know that, but some people, especially I know higher-ups and management in different organizations, just talk about GitHub and don't realize that there is a difference. So I'm just going to highlight the differences. You know, Git is the actual version control software that lets you manage and keep track of your source control, your source code history. So Git is the tool that actually allows us to do our SCM. It is actually the SCM tool that developers work with locally to, commit files, to, pull down changes, to do all these things. Git is the thing that actually keeps track of them. So Git came along first. Then providers like GitHub came along, and GitHub is a cloud-based hosting service that lets you manage your Git repositories. So GitHub, Bitbucket, there's a bunch of other ones out there that allow you to manage your Git repositories in the cloud. And so this allows you to take a Git repository that a local developer might be working with and share that with a larger development team. So that would become the remote. So I've got an illustration of this. So when we're talking about Git is something that developers work with on their local machines. So you install a Git client, and on the local machine, you can create a Git repository that can have, in Git, everything is in a branch. So you can have a main branch, which has a folder and multiple files. And you can make your changes, you can store that. I'll show you real quick. So let's say here I have a folder called Git demo. And in here, I can actually open a Git bash prompt. So this is basically a Git client. In this case, it's a bash prompt. It's a tool you get when you install Git. But you can do this in command prompt as well. The idea is that I have a Git client installed on here. And I'm in this folder called Git demo. And I want to initialize this as an empty Git repository locally. So I say git init, and now this is an empty Git repository in this folder. Behind the scenes, if you show hidden folders on your system, you actually see this .git folder. That's the thing that manages all the different versions and such. But now if I wanted to do, if I wanted to add a file in here, let me just add a new text file. I'm going to add a text file called file1.txt. If I do a git status, it's going to show you that, hey, there's an untracked file. So it knows that this is a Git repository and you have a file in here that's untracked. So I can say, hey, stage that file. Basically, I want to be tracking that file and I want to stage it to be committed. So now if I do a git status on this, it shows no changes to be committed or no commits yet. And it shows the change to be committed is this new file. Now, this is not a demo or this is not a tutorial on how to use Git per se. I have another video that walks through that. This is more high level, but I want to just give you a feel for what developers and how developers work with Git locally. So now if I do a git commit on here, I'm going to give it a commit message. And now I have everything committed. So this file is now being tracked by Git. And this version, which is an empty version of the file, is being tracked by Git. If I wanted to, I could actually add new text to this file, add something new to the file. And I'm going to save that. And I hit Control S to save that. Now I'm going to go back here. And if I do a git status, the Git tool is tracking the fact that, hey, this file has been modified. So I'm going to, if I want to commit those changes, I can say git add to stage it for commit, and then I can do commit new stuff. And you should give much better commit messages than I am for this demo. There's a tool I'm going to run called GitK that also comes with the Git client, that just allows you to see the different commits you have. So I zoomed in here a little bit. So it shows the initial commit and then the master commit. So if need be, I could roll back to one of these, but just want to show you that locally, Git is keeping track of the different versions of my file. So this has nothing to do with GitHub. This is all just about using Git locally. So I'm going to close that. So that's all I want to show with that Git client. But coming back here, I just want to show you that you can, within your local machine, you can also create branches Whenever you initially create a branch, it's actually the exact same. So if I branch off the main branch to create a feature branch, it's exactly the same starting out because they're actually just both pointing to the same commit, the same point in history. I can add changes to this. I can do all this. I can do merges. I can do all this stuff locally. So where does GitHub come in? Well, as we already mentioned, GitHub is one of these cloud providers of many that allows you to manage your Git repositories, in the cloud or remotely. So what I can do here as a developer is, hey, I can create my code locally and create a repo in GitHub, an empty repo in GitHub, and then link the two. Basically, I can link my local repository with that remote GitHub repo and push it. What's really cool about this is all the history I have, all the versions I have locally get pushed to that remote GitHub repository as well. And so this then allows me to share this code. So when I'm working on a large team, I have this GitHub repository in the cloud, and on another developer's machine, they can clone this repository, and they have all of the history, all the versions of the files, and even if there's multiple branches, would have access to all those different branches. They can then make changes, they can make branches, they can push those changes back up to the GitHub repo, which is the remote repository, and then this is how developers can share their code. So GitHub does more than just host the remote repositories. It actually provides a lot of useful tools, such as issue tracking, branching, pull request, merging, those kinds of things. So I'm going to show you real quick here. This is a demo application we're going to be working with. And I will actually go ahead and show you the app since I have it up and running. I know you guys are going to be really excited about the awesomeness of this application. This is a pet insurance quoter. I kind of went retro and kind of wanted to go back to the 90s with the scrolling marquee and stuff. But this is just a simple Angular app to demonstrate some stuff within Git and GitHub. The idea here is you can put in your pet name, the type, and the age, and you press the Get Quote button, and it'll show you how much you can pay for pet insurance. It's a super simple dummy application, just to highlight some things. But let's say that we notice there's an issue in there. So regardless of what you do, well, first of all, the cost is only $10. That's too cheap for pet insurance. And so let's say the business says that's too cheap. So they can actually go to your Git repository and open an issue. Someone outside of the development team can do it, or someone on the development team, either way can happen. And so right now, they show that, hey, the quote calculator has hard-coded return of 10, and it needs to be 11 because of inflation. So maybe the better description would be insurance cost is too low. But my whole idea here is just to show you that you can open issues, and you can keep track of issues right here along with your code base. You can have comments about those so people can discuss those, best course of action to fix this. And I will go ahead and show you the code. So if I go back to the code, it's a super simple Angular application. You don't have to know Angular. Here's the simple method that actually does the calculating the cost of the insurance. So there's a calculate quote method, which just returns a hard-coded value of 10. So let's say our issue is it's too cheap. So what's the process we should go through to fix this code? It's not really about the code, but I want to focus on the GitHub flow. And that is why I want to talk specifically about this thing. It's actually called GitHub Flow, and there's a link here. And I'm going to show you that kind of walks through this. So this is about understanding GitHub Flow. So what should you do? Well, what is GitHub Flow? Maybe I should start with. As it says here, it's a lightweight branch-based workflow that supports teams and projects where deployments are made regularly. This guide explains how and why GitHub Flow works. So the idea is that when you're first working, you have this main branch that you're typically deploying off of. And then in order to do a feature change or a bug fix, you're going to create a branch. So first step is you create a branch. Then you start making some of those changes. So you add commits. So you make code changes, you add commits. Then once you've tested, the developers tested everything locally, they can open a pull request. And this is a neat feature of GitHub that basically a pull request is kind of a request to pull my latest changes into another branch. So I've made some changes, they're in a feature branch, I want to pull those into the main branch. So that's a pull request. Once the pull request is open, similar to an issue, you can have a conversation about it. So people can leave comments. And anyone that goes to your GitHub repo can actually see the open pull request and any information about that. You can request for reviewers. You can do all kinds of things here. Another thing that you highly want to do is to probably kick off a pipeline to test the code automatically. You could even potentially deploy it. If you want to deploy this version of the code to test it out, to run some automated tests, that could happen at this point in time as well. Then eventually, through that pull request, you can actually merge the code. So this is what they call GitHub Flow, and it is the recommended way of teams that can regularly deploy. And hopefully most of our app teams are where we have enough automation, DevOps automation, we have enough unit testing, all that kind of stuff in place that we can regularly deploy our code and make code changes and feel comfortable quickly that it is going to perform the way we want it to, not only from a performance standpoint, but from a functionality and feature standpoint. So let's walk through this real quick. So I showed you the awesome pet insurance app, and right now everything returns 10. It doesn't matter what you put in here, if Fido's a dog or a cat. Well, anyways, the point isn't what you put in here. The point is that it's always 10, and we want it to be always 11 for now. So if I go to the code, here's the code on my local machine. I'm going to open up a terminal, and this is VS Code, Visual Studio Code, by the way. Care about the editor that I'm using, but it doesn't matter. What I'm going to do here is I'm just going to work with Git. So I'm going to, first of all, before I even make a change, I'm in the main branch right now. I'm going to create a feature branch. So we're going to call this increase quote. Increase quote. Yeah, this is my feature branch. So I'm going to check out. I need to add a -d. Again, this is not really a tutorial on how to do this, but the idea here is that I'm working on another branch. Now I'm in this new branch, which is off of master, because that's where I was, or the main branch. I'm going to make my code change. I'm going to save that. Now I actually have code. It's running behind the scenes where it'll automatically refresh my code, and values don't really matter. But now I can test. So hey, now I see that my code, the quotes return 11. I would do more, should do more testing, but just for the sake of this demo, we're going to quit there. I'm going to do a git status, and it's going to see, hey, that file is modified. Oops, apparently there's something else I modified, but that's all right. So we're going to say git add. Oops, I need to commit these. I'm going to give it a useful commit message. Oops. So we're just going to do what we did, and now I have this code change finished. Now it doesn't exist in GitHub yet, so this is all locally, so there's nothing new out here. I still only have the one branch, which is master, but locally what I'm going to do is I'm going to actually push this new branch. So I'm going to say, hey, take my local branch and push that. So if we remember the diagram, I can't go back so much. Let me see if I can. Yeah, so let's go back. Remember from this view, right? Locally, you can create multiple branches. We push the main branch, but we can also push feature branches. And that's what we've just done. So did I finish that command? Let's check. Yep. So it shows here that I've done that git push for this new branch. And if I look out here, it shows me that this new branch was pushed. So at this point, this is where I could create a pull request. So this is a developer has finished their feature, finished their bug fix, whatever it is. They've done that in a separate branch. They've done their local tests, they've made their commits, and now they're requesting to have this merged in. So I can say create a pull request. I could add other testing documentation or whatever else I wanted in here. Now, what should happen is that some automated checks should run. And you see, I actually have a pipeline. It's actually a simple Git action. And this is something this is actually a new feature of GitHub, that they now have these concepts of actions, which can automatically run on a pull request if you want them to. And that's what I have here. So what I have is now, as soon as this code, a pull request is created against the master branch, it is going to kick off some check. And it shows here that this check is in progress. And what this check is going to do is actually run some unit tests to see if, and that's all it's actually going to do. It's going to build a simple little test environment that can execute the Angular code and execute the unit tests. The longest part of this is actually building the environment to do that. So it's doing that, and as it shows here, the test has started, or the check has started. And I can actually click in here if I want to and see exactly where it's at. It's on running unit tests. Right now, it's setting up the environment still. But if I go back to the GitHub Flow diagram, so the idea is we're kind of back here. Discuss and review. There's actually a step they don't really have in here. It's kind of like your automated pipeline. And this is where it's really important to have this kind of check to say, hey, this pull request, before I merge it into the main branch, is it good to go? And this is where it requires having a good set of unit tests and maybe even potentially deploying this to an environment temporarily and have automated end-to-end unit tests run against it as well. But this is running. Something else you should do that's very important is on your main branch that you're deploying from, if you're deploying from to your test environments or even especially into production, you can actually go into GitHub and you can secure those branches. So there's branch protection rules. I don't have any, but I'm going to show you what you typically should at least add. So branch pattern name, so you can actually have what branches do you want this protection rule to go against. I'm going to say the master, I'm going to protect it. And here's one thing, you can actually require that everything comes through a pull request, so no one can commit directly to the branch. I'm not going to do that one for now, plus it also requires an approval. But this is something I would highly recommend. You require a pull request in order to merge into the main branch. The other thing is you can do require that status checks have to pass. Okay, so that means the little check that I'm running now, you can require that has to check or pass as well. I'm going to go ahead and say create, and then you have to give it your password. All right. So now any pull requests, will have to have a review and have all the checks pass. And if you see here, hey, my checks failed. Why is that? Well, it's kind of cool. I can go to the details, and this is using Git actions, and I can see in the step of running the unit test that there's a failure. And the developer before me was very good, and he wrote a unit test to verify that the calculate quote method should return 10. Okay, well, I went in and was a lazy developer and just made the code change and didn't update the unit test. And so that's why my code failed. So I need to also come in and update my unit test to verify that the calculate quote method now returns 11. So what I should have done as a good developer is I should have run the test. I'm not going to run them locally. I'm just going to add it. And I did this intentionally to show kind of the value of having these checks. So this would make sure that before it got deployed even to a test environment or anywhere, having this action run, it stopped my code from my bad, or actually my code probably would have worked, but the unit test wasn't there. So we couldn't have confidence if someone else came in and changed it accidentally, we wouldn't have confidence that it was good. So I'm going to combine my add and commit into a single message. And, unit test or calc quote. I am kind of giving rushed messages, but I'm going to push this again, and I'm actually being quite verbose with my commands, but I'm going to push this change. So now my unit tests have been there, and it should actually rerun my tests. So you can see here my open ticket was immediately updated, or sorry, my open pull request was immediately updated. Well, something else I forgot to add was a way to show you can actually have this when this pull request is finished, it can automatically close the issue if you wanted to. You can say things like fixes or fixed or closes, and then you can give it a issue number. So check this out, it even gives you content assist. So I can say that this closes number 4. And so when this gets closed, it will automatically close that. So you see here, though, also my check is automatically running again. It detected that this branch had a change, and now the action is going to run. So again, this isn't a tutorial on GitHub Actions. We're just trying to high level go over the whole flow, but it's highly recommended that you have some sort of pipeline, whether that's using GitHub Actions, Jenkins, Concourse, Travis CI, some sort of tool that can detect changes through your code and then kick off a pipeline to run tests on those things. And what we should see here in a second is that it's all good. Hopefully, assuming I did things right. But while that's running, I'm going to show you some insights, another cool thing that GitHub provides. If I go to Insights and the Network tab, kind of highlight and show what's going on here. Okay. So this is showing the main branch going out here, and then where I created my increase quote branch locally. Now, actually, I just now realized that I didn't do a git pull locally. I didn't update my local to pull in all the latest changes. So I might have an issue merging here. What all these changes are me creating the pipeline, the action, not the code, but just all the updates to get that pipeline or that Git action set up. But the key here is that you see the main branch going this way, and all these dots represents commits, and then my increase quote. And so this is a cool view into what's actually kind of going on. So if I go to my pull request, hey, look at there, I got a success. So my checks have passed. Now it still requires review. Let's see if I can review this. If not, I might have to take that check off. Normally you do to comment, and you can okay, I think because I am the only person in here, I can't review. So I'm going to take that check off for now. That requires a review. So branches, I'm going to edit this. All right, take that off. It still requires the checks to pass, but it doesn't require review, and I could commit directly to master. There we go. So my checks have passed. It doesn't require review anymore. I'm going to merge this pull request. Okay, I'm going to confirm the merge. All right. So now the my code has been merged into master. Now I want to show you something here. It's also very useful at this time. You can delete the branch. But before I do that, I'm going to show you the Insights tab again in this network graph, and we'll see what happens here. Because now what you should see is a merge where the branched line below has now the new feature branch that I created would be merged in. Yep, and there you see it. It's kind of hard to see with the labels. I'll remove those for a second. So what you see, here's all the commits. Here's my branch. I increased the quote, and then I fixed the unit test. So these are the different commits. And then now I got merged back into master. Hey, let's see if it closed our issue. Okay, this did not close it. I think it's probably because I didn't comment properly there. So this message is still, this pull request is still open. If I look at my closed one, closed pull request, So I think the problem is I didn't have this in the main description. Could be it. Anyways, now that this code is merged in, there's no reason to keep this branch around anymore. So I'm going to delete this branch. Now you can do that through the pull request, or you can also always go to the code and then the branches tab. And I'm just going to delete this increase quote. So I don't need that anymore. All that history is now up in here. Now, actually, if I refresh this here in a little bit, this other branch, yeah, okay, you can see it shows this history, and the branch name is now gone, but that commit history is all in here. So, as a developer, I would actually have to now go back to the main branch and do a pull to get all those changes. So you notice as soon as I switched branches, it took me back to the old code in my old, my local version of the main branch. So now if I do a git pull though from here, it's going to pull the latest code from the Git repository or GitHub repository. So now I match with whatever is out in GitHub by doing that git pull. So now I'm up to date. All right, so I'm going to take a moment to highlight the importance of having good unit tests and a pipeline, and also having short running branches. Before I do that, I did actually I did find the problem with our pull request. Why our pull request didn't close our issue. Now through the magic of video editing, I actually have paused the video, went in and actually added some more issues. But the issue we initially created that you saw me create, where insurance cost is too low and increase it, you notice this is issue number 3. And so the reason our pull request didn't close that automatically is that our pull request said it closes issue number 4, which is non-existent. So anyways, that's why that tie didn't work in. Otherwise, I think it would have automatically closed this issue. I'm going to manually close this one. And I could actually say fixed by a certain PR, but I'm just going to close. All right, so that's done. So now if I go to issues, we have these 2 open ones, so 2 new issues. So the idea is that I'm going to call it release 1 and release 2, which is actually a horrible idea. I shouldn't say horrible idea. You can have releases. We typically have seen a lot of issues when you have long-running release branches, meaning you choose a certain set of features that are going to go in a specific release. And then you have branches. No, that's not bad. Choosing features that are going to go in a specific release, that's not a bad idea. But saying that we're going to have a specific branch for that release can sometimes cause issues. Anyways, if it's long running and there's not a lot of merging, and more importantly, there's not a lot of unit testing. So lots of times it's better to have short running feature branches and always merge back into the main branch. Features that aren't ready to go or shouldn't be going, you should use feature toggling or what we call dark launching. So you can dark launch the code. It's not actually active until some other point in time where you switch a flag in the database or some properties file or something to then activate that feature. But let's say we're going the route of long-running release branches. And so one of the issues they have is they want to give discounts based on pet name and type. So I am going to do that. Now I'm going to actually do the, let's go here. Let's go to VS Code. I'm going to do this, show you how a local developer would do it. So I have all of, this is actually the code we're going to put in here. Let's see, where am I? All right, so let me make sure. So right now I'm in master. I need to fetch all the latest information from GitHub, and then I'm going to check out the release branch 1. Oh, so what I've done is I've actually created two branches as well. Oh, no, I haven't. I need to create 2 branches. I've got 1 branch. I'm going to create a branch called release 1. Release 1. Create that, and then I'm going to create a branch called release 2. And again, this isn't something I recommend. I typically recommend that you do trunk-based development, or basically you have one main branch and you're doing short-lived feature branches off of that and then merging into the main branch. And that's what Github Flow recommends as well. So I have these 2 branches. If we look back at the Insights tab, in the network view, we should see that we basically have 3 pointers branches to the exact same commit, because right now the master and the release 1 and release 2 branches are all pointing to the same commit, same point in time. So what I'm going to do is as a developer, I'm going to check out, oops, I need to fetch again because I just created those branches. So now I can check out release 1. So now I'm going to release 1 and I'm going to make this change. Let me copy this change I have here, and we're going to change the calculate quote service so that based on the name and type, you can get a discount. So let me save that. And I believe my application should refresh. So let's try this. So if my pet's name is Garfield and it's a cat, it doesn't matter the age, the insurance is cheaper. Why? Because you have to have a lot of money for lasagna if you're going to have a cat named Garfield. That's maybe too old of a reference. What's the other one? Oh yeah, okay. So if you have a bird named Tweety, it's going to cost you more because you always have to worry about that Sylvester getting to your bird. All right, what was the other one? Oh yeah. So if you have a coyote, which I'm not sure I recommend a pet coyote, but if you have a pet coyote called Wiley, it's going to cost you a lot of money because that thing's always getting into trouble. All right, so that's our change for release 1. I've made those changes. I'm going to commit those changes. And actually, before I do that, check this out. The default cost got broke. Got lost. Oh, that's a good reason for unit tests. All right, so I'm going to leave that. I'm going to commit this change, added discounts for type and name. So now I'm going to push my change to the release branch. And we're going to check out GitHub and see what's going on here. Actually, let me see. Hopefully that got pushed by now. I'm going to refresh this. I'm also going to go back here, refresh this, and it shows, hey, we've had changes less than a minute ago. So release 1 has a change. All right. So see, release 1 is now ahead a little bit. So we see we've got release 2 and master are still pointing to the same commit. Release 1 now is 1 commit ahead. All right, so it's got a new change there. And this goes from left to right, it goes in time frame. So newer commits go to the right. All right, so now let's say I'm a different developer. And I'm actually going to make the change in release 2. And that change is to give a discount for goats. All right, so let's go back here. So I'm going to change this method. Now notice this method that we changed for release 1, we don't have that change. Let's pretend this is a long-running process, right? Release 1 is going on, they're making their changes. Release 2 is going on, development at the same time, and they're making those changes as well. I'm gonna fix this code, it's slightly wrong there. Well, I guess it works either way, it's just buggy. So not the best code, don't look at the code. This is not how to do this coding. So I've saved that. So actually now if I check my code base again, let's see, it doesn't matter what I have. I think the default it's going to be 10 again, yeah. But regardless of what the name is, if I have a goat, I should get a discount. There you go. So I've tested the change. Now I'm going to commit that change. What am I doing? Yeah. Added goat discount. Oh, okay. So let's say actually I'm still working on this, and in the process, the meantime, release 1 is still going on, right? So before I push this change, what I'm going to do here is come back out here, and I'm going to actually create a pull request. So release 1, I'm going to create the pull request. All right. And I'm actually going to go ahead and merge this. No, actually, I think I stopped it before the automation kicked in, but let's see here. So now if I go back to the Insights tab, let's refresh this. There we go. All right. So if we notice here, so this green line is release 1. Did I do that right? Uh-oh, what did I just do? Okay, release 1 got merged into master. Release 2 points back to here. Okay, so that's all right. So everything's good. I got scared for a second. I got confused. So release 2 is still pointing back to this point in time. Release 1, we made a commit, but then we also now just merged that. So release 1 is now merged into master. Release 2 is still pointing back here. So if I make this change, if I push this change to release 2, so again, this is another development team. They made their changes to release 2. If I refresh this now you can see here's where we're at. So release 1 was already merged into master. Release 2 is making changes. So what happens now? So I can go to code. I can open a pull request. And now this is the first time we've seen this. Can't automatically merge. Okay, so we can still go and create the pull request, but the issue is the same file, there's a conflict, and it tells you that, hey, the same file was both changed in release 1 and release 2. So we've got to merge that. So the way you do that merge is the developer would locally, first of all, realize their pull request can't be merged automatically. They'd have to do it on their local machine. So what they would do is say, do a git fetch to get all the latest information. Actually, I'm going to have to check out master, because what I have to do is I have to update. I'm trying to merge release 2 into master. All right, so go back here again. If I'm trying to release or merge release 2 back into master, I have to get these updates before I can do that. Specifically because I have a conflict. So I'm going to pull the latest code for master, so make sure my master is up to date. And then I'm going to check out my release 2 branch again. And then I'm going to locally try to do the merge. Git merge master. So I'm basically going to say merge master into my release 2. And it's going to tell me, hey, it can't do that because there's some conflicts. And I have my fancy VS Code extension highlights these. Actually, I think it's a default extension with Git that highlights the differences. So here's what's in one place, here's what's another. Now it's up to the developer to manually merge this. Now these buttons allow you to accept incoming, accept both, do whatever. But it's still up to the developer to manually merge these. So I'm going to be the developer and take out these things that Git inserts, those lines, and I'm going to manually merge this. So here's the goat. So I know, let's say, yeah, I'm the goat developer, so I understand the goat requirement pretty good, but I don't understand this other one. And let's say I accidentally delete a block of code. So which, believe it or not, developers do make mistakes. I know it's shocking. But let's say as a developer now, I've made my changes, I saved this, I can go out here and test. Hey, I'm the goat developer, so that's the one. Goat developer, that's a new term. But anyways, okay, I see my goat feature still works, right? Let's say I know there was something, because I always loved Wile E. Coyote. I know there's some sort of thing with that. Okay, yeah, so that works. And maybe there's something with a Tweety bird. Okay, so all that, and by default, it's $10. Okay, actually it's supposed to be 11, but that's all right. Let's say, so the developer can manually do the merges, and yep, they can see that. I can then say, hey, well, I've made those changes, and I've fixed all the changes. I can say merge changes for release 2. And now if I push this, I'm going to push this back in here. So imagine, again, this is happening. I'm doing this back to back to back. But imagine a developer that has to stop and do this merge conflict. Could be weeks, months later, depending if these release branches are running a real long time. If you're waiting a long time before you do these merges, these merge conflicts pop up, and you have all these issues. All right. So my checks are running. And I was able to actually merge the last time without the checks because I don't have it actually requiring that all the checks pass, I think. So I'm just going to go and merge this even before the checks fill. Because let's say I don't have good unit testing. Actually, I don't have great unit testing. I have some unit testing. Not. So I confirm that merge, but if we know that now, so the code that I had locally, I merged it, but I lost a feature. Because if you remember, let me get back to the app. Remember my Garfield? If I had a Garfield cat, I should get a discount. But I don't. That code no longer exists. And I can even show you if I go check out master and do a git pull. This is basically pulling all the latest codes from master. I've lost that. I've got my goat discount. I got my Tweety bird, and I've got my coyote that's wily. But I've lost that other change. And this is a very common issue for teams that don't have unit tests, a good unit test suite or automation test suite. Also, it's very common when you have long-running release branches. So the fix to this is to have this check required, which I kind of got around it, but you can make it required so that check has to run, running your unit tests. And the other thing is to write good unit tests. So I do have basically a good unit test. I should say it's an okay unit test suite. You should spend a lot more time on this, but so here are all the unit tests. So as a developer, when you're making changes, you should change the tests as well, or actually preferably you could follow like test-driven development and write your tests before you even write your code. So this is going to test that the default is 10. I know we changed it to 11, but we'll just say 10 for now. Should return 7 for goat, return 8 for cat, return 12 for bird Tweety. And the nice thing about the unit tests is these unit tests are not testing the deployed application. Let me save this. Let me run this. This is actually testing the code. So when I say it's not testing deployed application, the application doesn't have to be completely deployed, and it's not actually hitting a browser to test all the code, going through and filling out text fields and clicking buttons. It's actually testing the actual code. So if something fails here, you know exactly the piece of code that broke. Versus end-to-end testing, when you're actually testing by going through the website, so hitting the deployed application, that's going to be a problem. If you're going to get the end-to-end application, so you're actually have scripts that run that fill in text boxes, click buttons. If something goes wrong, you don't know the piece of code that broke. You know something went wrong, but then you have to do some investigation to find out the code that broke behind that. So this shows us that, hey, we have a test. So this is assuming that the developers wrote good unit tests. And so it had the test in here for Garfield. And it tells me when I run my unit test, hey, calculate quote should return 8 for cat Garfield. So wow, okay, that's cool. So the unit test also captures the requirement. So now if I was doing this merge, the release 2 merge, and I would have ran my unit test, or my pipeline would have ran when I opened my pull request to run the unit test, I would have immediately got the feedback before the merge happened, hey, I missed a requirement. So now as a developer, I can go in and make that change. I can actually go back in the history if I wanted to and get and see that. But I can also manually add it. Since the requirement is there, I know that if it's a cat and its name is Garfield, it should return 8. So now if I save that, my unit tests are going to run again, and look, everything's successful. So now I can have confidence that I fixed this. And we shouldn't trust developers. I hate to say that as a developer. Meaning we should always require the unit tests to be written. We should always run those unit tests as part of our pipeline, whether that's using Git Actions or something else, and that will save us. So because last thing I want to mention, I've heard an IT definition called stabilization or stabilization period. I define that as a long period of time to test an application before moving to production. But it's only required when there are insufficient unit tests and automated tests to inspire confidence in your code. So if you don't have a good unit test suite and a way to even test the deployed application with automated end-to-end testing, that's where you have these teams that cannot deploy quickly. They have these long stabilization periods where you have to merge all the fixes into the main branch after a long period of time, merge all the features in there, and test, and make sure you didn't lose anything through the merging process. So you don't ever want to have a long period of time between commits to a branch and then that branch being merged back in. So you don't have long running branches, because by the time you merge it, when you have conflicts, the developers are probably working on something else. They have to stop, come back, figure out what's going on, and then try to fix that issue. And if they have good unit tests, it'll be a lot easier for them to feel confident that they didn't break anything else. But it also requires a lot of context switching. So the quicker you can have between a branch being created, commits being done, and it being merged back in, the better off you're going to be. So one last time, we'll look at this, and we'll see here that we now have release 1 and release 2 both merged in. Now, ideally, to fix the problem, I didn't actually go through the final fix, but we see release 1, release 2 was merged in. I would probably open up another branch with this change. I would open up another branch with the change that I just made, the fix, and then open a pull request and merge that in to fix the issue. But that is my video for today. Hopefully it was educational and informative. Please feel free to throw your questions down in the comments or reach out to me if there's anything else you'd like to learn. Be sure to tell me what you think we should code next. Thanks for watching.